This is the third video on the National 5 topic of circle geometry. In this video we'll look at tangents. Okay, so over on the left here, the definition of a tangent. A tangent is a straight line which touches a circle at only one point. And if we look at the diagram, I've got my diameter drawn through the middle here with 2 points of contact, one on the left, one on the right. Dropping down, I've got my chord, also 2 points of contact, one on the left, one on the right. Dropping it down even further though, I've got my tangent where it touches just at one point there. It's almost as though the circle's sitting on it. Now, wherever I have a radius and a tangent touching, it forms a right angle. So this is what I've said here. The angle between the radius and tangent at the point of contact is always 90 degrees. So, on the diagram on the right here, I've drawn two radii in. Looking at the lowermost one, my radius and my tangent meet at this point here. So I've got a right angle there. So it's worth noting there'll be a right angle at that side as well. Similarly, your tangent doesn't need to be sitting down the bottom. I've got one up at the side there. A tangent meets a radius and it's formed a right angle on each side. So it means we can solve a bunch of problems like we've been doing previously, so finding missing angles. We'll also be able to apply Pythagoras and some trigonometry to it at a later date. Just draw your attention straight away to this little bit of extra information which isn't in your notes. I want you to, or we're going to find the marked angles in each diagram, given AB and AC are tangents. So, looking at the left-hand side one first, I've got a radius to my circle, and I've got a tangent. So straight away, that lets me identify this bit here as a right angle. So I've marked that on my diagram. So that means the angle X is 90. Three angles in this triangle, so they have to total up to 180. So I can do 180, take away the total of 90 and 37. So that would give me 53 degrees. This right-hand diagram looks like a sort of kite shape. We've got AB and AC, our two tangents. We've got our two radii here coming out from the centre O. So it means we've got two right angles. I've got a right angle in there, and I've got a right angle in there. This means U, well, 63 plus U makes my right angle. So subtracting 63 from 90 will give me 27 degrees. So I know this in here would be 27 degrees. I know the two lines OC and OB are both radii, so they're equal. So I formed an isosceles triangle. So this means the angle V is also going to be 27 degrees. W, that's the third angle in my isosceles triangle there. So I know the three angles have to add up to 180. So my 27, my other 27 degrees there. So subtracting them from 180 would leave me with 126 in here. If you guys were doing problems like this yourselves, I would recommend drawing a nice big diagram so you can annotate it like this. I'm obviously running a bit tight for space here. The angle X here, there's a couple ways we can figure this out. Again, notice I've got 27 plus x makes a right angled at the point of contact there. So I could take 27 away from 27 away from 90 to be left with 63. But it's this fact we've got a kite shape. I know these two lines are equal. I know these two angles are equal. So that forces these two lines to be equal as well. I've got a kite here, two pairs of equal sides. One of the properties of a kite is the fact it's symmetrical up the middle like that. So, getting rid of my coloured lines, it basically means the top half, so everything from my line of symmetry down the way, is going to match with everything up the way. So it just means x has to be equal to that 63. Two things left to find. I've been asked to find the angle y. There's a couple of ways you can do this. Again, notice how if I look at the top half, where I've got, well, half of 126 here, I've got my right angle. So I could use the fact that that's a triangle and the angles add up to 180. But it's also worth noting that if you've got a quadrilateral, a four-sided shape, the angles in that will add up to 180 as well there. So it means two lots of 180 will give 360. The angles in any quadrilateral, in any four-sided shape, should total 360. So if I take away this angle, and this angle from 360, I'll be left with this angle here. So lots of ways you can do this, okay? That's quite a useful fact to know. The four angles are 360, but if you can't remember that, you can rely on splitting this shape up into a triangle and then using the symmetry to match that up. The symmetry, again, the symmetry is quite useful to know because it helps us find Z. Notice Z's not an angle, it's this side. This side is equal to this side. Probably more useful if I use my dashes. So it means Z has to be 43 millimeters. Okay, a few more there on that page. I would recommend trying to spot radii there for my isosceles triangles. You can have a go at those, but we will look at them in class.